In this video, we're going to talk about the ellipse. The ellipse is also a figure that can be derived from a cone, so it's called a conic section. So I have the definition for the ellipse. This is the set of points in a plane, the sum of whose distances from two fixed points, called the focus points or the foci, is constant. Okay, so I want to draw a couple pictures for you. First, this is a shape that we can get from a cone. If we take a cone with a circular base, if we were to slice it, kind of like this, we would get, we wouldn't get a circle, we would get sort of an oblong type of shape. And if we were to make a really thin slice and lay it flat on the paper, you would see that it would look like an ellipse. So when it says here the set of points in a plane, that just means that this is a two-dimensional shape. And so I'd like to kind of draw out for you what the rest of this means, whose distances from two fixed points is constant. So I'm going to draw out an ellipse just as an example, and then we'll kind of label it to go along with the formulas that we're going to put up in just a second. Okay, so I'm going to make this a horizontal ellipse. I like to think of this one almost like a football shape. So it's a lot like a circle, but it's not equal distances from left to right as it is from top to bottom. At least it's oblong, right? It's an oval. So first of all, there are focus points inside the ellipse, one on each side. They're symmetric with the center. Right now we're just going to work on ellipses that are centered at 0, 0. So what this definition says is that if I were to pick any point on the ellipse, I'm just going to pick a point right here. Any point on the ellipse, if I were to measure the distance from that point to one focus point and to the other focus point, let's call this distance 1 and let's call this distance 2. The definition says that the sum of these distances is constant or fixed. So it could be any number. Actually, it may be a specific number based on our shape, but either way, it's always equal to a fixed number, a constant. Right? And so that's kind of what the definition is saying. One of these days I'm going to make some push pins, right, with a string. I'm just imagining my string pulling, or my pencil pulling this string taut and kind of working my way on either side, and then doing the same thing down here and working my way. And I think based on that definition, we will get this shape of an ellipse. There's some other vocabulary that go along with the ellipse because the left to right distance and the up and down distance are not the same. We call the longer line connecting the outermost points, we call that the major axis. So for this, I'm going to write this down in the corner. This is a horizontal ellipse. It's longer horizontally than it is vertically. For this one, the x-axis here is the major axis. Right, it happens to be the x-axis because we're centered at 0, 0. If I shifted it up or down, right, it wouldn't necessarily be the x-axis, but it would be a horizontal line if the parabola was horizontal. Okay, and so these points at the ends are called the vertices. And so let's call this is labeled in the formula as A. or a comma 0, and negative a. Then we have the minor axis, which is the axis that has the shorter line connecting the outermost points. So this would be the minor axis. Okay, and this we usually label with a B, so a B and a negative B. And then the focus points are always going to lie on the major axis, and these are usually labeled with a C. The plural of focus points, or plural of focus, is foci. So that's what that's talking about. Okay, so now that we've kind of labeled everything and you can see where the shape comes from, let's show you the formula. So the equation, or the formula for an ellipse with center at 0, 0 looks like this. So we have x squared over a squared plus y squared over b squared equals 1. Notice there's a plus in the middle, just like there is for a circle. And if these two were the same, let's say this was a squared and this was a squared, then we wouldn't have a longer side, right? It would all be a circle, and we could kind of multiply it over to the other side and match what we were looking at it as far as a circle in the last video. Okay, so if the axis is vertical, so if the longer side is not on the x but on the y, so it's sort of, we rotate it 90 degrees so that it's up, the taller length is vertical, then the formula looks like this. For both of these, and I don't think I have this typed in here, I missed that, but the A is greater than the B. So we look for, is the larger number under the y? In that case it would be vertical, or is the larger number under the x? In which case it would be horizontal, like it is here. Okay, and then we've jotted down the vertices, just like we said, at A and negative A. They're on the x-axis for this horizontal ellipse. The B and negative B are on the minor axis. I did not label this correctly. All of these should be for this. I will send you a formula sheet with everything labeled correctly, since I've kind of goofed here. This is not correct. I'm sorry. Should be 0, comma B, or 0, comma negative B. Okay, and it would be reversed for the vertical. So I'm not going to write those here, but everything we have written here actually applies to this horizontal major axis, just like the picture we just drew. Okay, one other fact that's kind of hidden in here is the relationship between the A, B, and C. So C squared is equal to A squared minus B squared. And because the C is inside, it's definitely going to be smaller than A, and so hence the subtraction, right? Okay, we just talked about if A and B are equal, we would have a circle. Okay, there's the string length. So the string could stretch, right? If I picked a point over here, it would be the distance from this foci to this foci. Okay. All right, so let's take a minute and graph an ellipse. Let me try to put the formulas up here for you. When you are making the graph, it is a good idea to start by finding the A, the B, and the C. Okay, and for the ellipse, like we said, the bigger number is going to be generating the A, and the smaller number is going to be generating the B. So I can look here, a squared must be this larger number. So a is going to be the square root of 169, which is 13. Why don't we do this? I'm just going to write it as 13, and in a minute we'll add in the plus or minus, right? Okay, the 25 is going to generate the b. So if we took the square root of both sides, looks like b is 5 in this case. Then we have the relationship for c. Remember, c squared is a squared minus b squared. A squared is 169. B squared is 25. If I subtract those, I get 144. And if I square root, that tells me that c must be 12. Oh, before I move this out of the way, is this ellipse going to be horizontal or vertical? Since the larger number is under the x, that means it's going to be longer on the x-axis than the y. So this one is going to be horizontal. I think it's good to jot that down as well. All right, so I've given us a grid here. So this one, like we said, we're just going to worry about graphing ellipses that are centered at 0, 0 for the moment. So because we're horizontal, we're going to measure 13. Here's my axis right here. We're going to measure 13 on the right and on the left from the center, 0, 0. So 9, 10, 11, 12, looks like it's all the way at the end. So 13 here. And then I'm sure I made it symmetric, so 13 on this side. Okay, and then the endpoints of the minor axis are going to be given by the b, and these are, notice the b is under the y, so 1, 2, 3, 4, 5 up here. Extend that. And then down here. Okay, then we can go ahead and draw the ellipse. I did an okay job at that. Not really. I probably could have made this rounder, but that's okay. The C, remember, gives us the focus points, and it's always going to be on the major axis, which is the longer one. So this one is at 12 and at -12. So let's jot down these points that we're talking about here, because you're going to be asked to list these out. So the vertices, these are the endpoints of the major axis. So they are at 12, 0, and -12, 0. I'm calling these the endpoints. Sometimes they're talked about as the endpoints of the minor axis. So these are on the y-axis, so this would be at 0, 5, and 0, -5. And then we have the focus points, or the foci. Those are always inside the ellipse on the major axis. Oh, I did that wrong. I'm sorry. This should be 13. And -13. Because the focus points are at 12 and -12. Right? We get these from the value of A, we get these from the value of B, and we get these from the value of c. All right, so hopefully you can kind of follow that process to give yourself a chance to see where everything joins into the formula for an ellipse. Let's try one more. Okay, so again, let me bring this down. What is going to be the value for A? Remember, A is the larger of the two, so that means A squared is 36 for this one. If I square root both sides, that means A is 6. B squared must be 16. So that must be B is 4. Okay, and then we said C squared is going to be A squared minus B squared. So for this one, that is 36 minus 16. So C squared is 20. And if I take the square root of both sides, C will be the square root of 20. And I don't have that written here, so let me calculate that because we're going to need to plot it. So we'll put square root of 20 into our calculator. I'm not seeing. Oh, here we go. Square root of 20. Sorry. That's going to be 4.47. I'm sorry that took me so long. I'm not used to using the calculator on my computer. Okay, we're going to need to plot that, so we need to know, is this ellipse going to be horizontal or vertical? Notice the larger number is under the x. So that means that this one is also horizontal. All right, so let's graph this. The A would be 6. It's horizontal. The A is under the x, so we're going to count 6. 1, 2, 3, 4, 5, 6. 0, 0 is our center again. And then 6 to the left. The endpoints of the minor axis are on the y. So that's going to be at 4 and negative 4. So we'll draw the ellipse. This one's not as thin as the last one, but it is not a circle. So it looks sort of like that. The focus points are going to come from the value of C, so they are 1, 2, 3, 4.47, so roughly 4.5. 1, 2, 3, 4.5. So it looks sort of like that. And then let's go ahead and list out the values down here. So the vertices would be, this one is horizontal, so 6, 0 and negative 6, 0. The endpoints would be 0, 4 and 0, -4. And the focus points, or the foci, this is that square root of 20. You could put the square root of 20 if you want to be exact. We needed the 4.47 to plot. Either way is fine. I'll go ahead and put the square root of 20. Remember, those are going to be on the major axis, so that this time that's the x-axis. All right, well, I hope this helps you get a little bit of an idea of what the equation of ellipse look like and their graph. Take a chance to practice this, and we'll see you in the next video.